So welcome. In this short video lecture, we are going to give more examples on application of Gaussian elimination method to solving systems of linear equations. So the system that we start solving is given by x1 equals to minus x1 minus 3x2 plus x3 equals to 1, 2x1 minus x2 minus 2x3 equals to 2, and x1 plus 2x2 minus 3x3 equals to -1. So the first step is to arrange the system given in augmented form. So our solution, the first step is to have the augmented matrix. So solution. So augmented matrix or augmented form. So we have 1 minus 3, 1, 2 minus 1 minus 2, and then 1, 2, 1, 2 minus 3 minus 1. So this is the first step, to have the augmented matrix. And then step 2 now, from this augmented matrix, 1 minus 3, 1, 1, 2 minus 1 minus 2, 2, 1, 2 minus 3 minus 1. Because we have 3 equations, then we expect that our row echelon form matrix will be of the form 1, 0, 0, 1, 0, 1. So we expect to have this pattern. So already this is 1, so we don't interfere with row 1. So we say that row 1 to remain to be row 1 because we have the leading 1. And then row 2, this should be 0. So therefore we'll use row 1 to correct row 2. So we say row 2 plus. So the constant to multiply by 1 so that when we add to 2, we get 0 is -2. So put here -2. And then row 3, let's just do step by step. Let it remain to be row 3. So that step will lead us to this form 1 minus 3, 1, 1. And then so 2 plus minus 2 times 1 is 0. Minus 1 plus minus 2 times minus 3, that's -1 plus 6, that is 5. Minus 2 plus minus 2, that's -4. And then 2 plus minus 2, that is 0. And then, so this will be 1, 2, minus 3, minus 1. Now we have achieved this to be 0. So therefore we say row 1 to be row 1, and then row 2, let it be row 2 first, and then row 3, let's make this one 0 by saying row 3 plus, we still use row 1 to correct that one. So we need to multiply by -1 so that when we add, we get 0. So this will give us -1 minus 3, 1, 1, 0, 5 minus 4, 0. And then this will be 0. So 2, minus minus. So that would be 5. Minus 3 plus minus 1 is minus 4. And then minus 1 plus minus 1 is minus 2. So we'll have minus 2. So that's what we have. And therefore, so this is 0, this is 0. So next step is just now to ensure that we make this 1. So you say row 1 to be row 1, and then row 2 to be 1/5 row 2. And we can as well say row 3 to be 1/5 row 3. Or we can as well just leave row 3 the way it is. Deal with row 2 first, adjust this to step by step. So let row 3 remain to be row 3. So this will lead us to 1 minus 3, 1, 1, 0. So this will be 1 minus 4/5, and then 0, 0, 5, minus 4, then minus 2. And so we expect to have 0 here. So therefore we say row 1 to be row 1, row 2 to be row 2, and then row 3 to be row 3 plus row 1, row 2. So we need to multiply this one by minus 5. So that will lead us to 1 minus 3, 1, 1, 0, 1, minus 4/5, 0, 0, 0. Now minus 4. So when I multiply this one by minus 5, so minus 4/5 times minus 5, I'll get positive 4. So positive 4, this will give me 0. Then you have minus 2 plus minus 5 times 0. So just have minus 2. So because this 0, so then this is the row echelon form of the matrix. So from which we have the system that would be x1 minus 3x2 plus x3 equals to 1, and then x2 minus 4/5 x3 equals to 0, and then this just 0 equals to negative 2, because every variable is multiplied by 0. Now, because 0 cannot be the same as minus 2, so that's an absurd statement. So since 0 equals to negative 2 is a false statement, it's not possible for 0 to be the same as minus 2. Then we conclude that the system has no solution. So this system that we are given here is an example of an inconsistent system. a system that has no solution. Good. Now, if I have next example, example 2, solve the system x2 minus x3 equals to 0, x1 minus 3x3 equals to -1, minus x1 plus 3 x2 equals to 1. So if we have to solve this one now, solution. Remember, we said that the first thing is to arrange in augmented form, and any equation that doesn't have a given variable, which considering all the variables under consideration, you replace by zeros. So we can write this one as 0x1, and write here plus 0x2, and then we can write here 0x3. So that we have augmented matrix is given by 0, 1, minus 1, 0, 1, 0, minus 3, minus 1, and then minus 1, 3, 0, 1. So this is the augmented form or the augmented matrix from the system. So next, now we carry out the row operations. So for row operations, also because we have 3 equations, then we expect to have this pattern. The general structure of such an arrangement is this staircase pattern. So you see, this is expected to be 0, but it's not. It's expected to be 1, but here is 0. But you see, when you check the second equation, you see it has a leading 1. So we can always switch the 2 rows. So 0, 1, 1, 0, minus 3, minus 1, minus 1, 3, 0, 1. So we say row 1 to be interchanged with row 2, and then row 2 to be interchanged with row 1, and then we keep row 3 to be row 3. So this will give us now 1, 0, minus 3, minus 1, 0, 1, minus 1, 0, minus 1, 3, 0, 1. So by switching the row 1 and row 2, that's what we obtain. And so we have now a leading 1 in the first row. Good. So therefore now our next step, we now let this new row 1 to be just row 1, row 2, because already this is 0 and this 1, then we don't interfere with it, we just say row 2 to be row 2. But then row 3, this must be 0, so we say to be row 3 plus a constant times row 1. And the constant to put here, so that when you multiply by this and you add to this one is get 0, must be just positive 1. So that leads us to the next step, which is 1, 0, minus 3, minus 1, 0, 1, minus 1, 0. So -1 plus 1 is 0, 3 plus this is 3, and then 0 plus minus 3, then 1, this will be 0. Good. Now we expect this to be 0. So we say row 1 to be row 1, row 2 to be row 2, but then now row 3 to be row 3 plus a constant row 2. And what you need to multiply by 1 so that when you add to 3, you get 0 is -3. So we'll have next step 1, 0 minus 3, -1, 0, 1 minus 1, 0. So we'll have 0 and then 0 minus 3 plus -3 times -1 is 0. And then 0 plus -3 times 0 is 0. So this structure is what we call the row echelon form. So from which we have the system x1, then -3 x3 equals -1, x2 minus x3 equals to 0, and the last one means 0 equals to 0. Now, in the third equation, 0 equals to 0 is a true statement. So therefore, we say 0 equals to 0 is a true statement hence to get to solve for our system. Also there, hence we just use the first two equations to solve the system. i.e., we are using this x1 minus 3x3 equals -1 and x2 minus x3 equals to 0. Now, in this case, this minus. In this case, x1 and x2 are called pivot variables. So pivot variables are variables which have leading ones in the row echelon form matrix, and x3 is a free variable. So free variable is a variable free variable. A free variable is a variable that has no leading one when you reduce the system into row echelon form. So free variable can take on any real number. So therefore, that is what we fix to be the parametric variable. So we say, so let x3 to be t, where t is any real number, and this t is a parameter. So therefore, we'll have from this second equation, x2 equals to x3, and because we are saying x3 is t, then x2 is also t. Now from equation 1, x1 equals to 3x3 minus 1. So which means x1 will be 3t minus 1. Hence, the solution set is x1 is 3t minus 1, x2 is t, and x3 is also t. So this is the solution. And remember to specify that t is a real parameter, a real number. So this is a case of a system that has an infinite number of solutions, because any value of t you pick, you'll get a set of values that satisfy the equations. So this was an example of a system with infinitely many solutions. Infinitely many solutions. So that's how we solve it. So in the next video, we'll also give an example on using Gaussian elimination method to solve a system involving 4 variables. So thank you.